I now request our sponsor, Sonel Instruments, Mr. Shyam Ravindran, to do a small presentation. I want to thank them for keeping us, this event is successful because of people like you. Thank you.
Good afternoon, one and all. Audible? Yeah. Until I get my presentation, I was told by the organizers I have 8 minutes, so I will not stand in the middle of your lunch. As Mr. Gopakumar was addressing the scenario in the beginning, testing and inspection, we are a kind of a neglected people, or this is a department which is kind of neglected, testing and inspection of the system. Okay, so today's my presentation will be about decoding measurements according to NEC 23. Thanks to the wise gentlemen who presented before me, the technical aspects of how the design elements already looks and how it is being it is installed is already explained. So let me go quickly about the testing phenomenon in NEC 23. Now my agenda will be quite simple. We will talk about the measurements in NEC 23. I'll talk about the measurement techniques, the products and tools that is used, a quick overview about my company, and if you have any questions, I'll be happy to answer the questions. Now, before I get into the session, I wanted to make a statement. As I stand here, I'm also a victim of electrical fire accidents. It was a couple of years before, the place where I stayed, there was an electrical fire accident. So imagine a scenario. You are a manufacturer of the testing equipments. You have crores of equipments of assets with you which can help the country to do the testings. And you yourself will become a victim of an electrical fire short circuit accident. It changes the day. It changes the scenario, how you see the system moving forward. In fact, I had given a call to Mr. Gopakumar when we had that an electrical accident about it, or just a couple of years before. So that actually made me quite regulated. So only when certain areas that can be neglected, the possibility of a fire accidents are there. So it is not that we don't follow the safety regulations also. It is that how forcefully we try to implement, and equally what is the value of the asset. Here, the value of the asset is a human being. So we can take it for granted or no. I will leave the question with the audience. So before we get into the measurement techniques, as all the presentations happened before, there are 3 topics which we were all referring to: 732, 3043, and 60364, which is the international standard, and the NEC 23. So these are the 4 documents which we refer to. One quick point is, this is the 4th revision, and that is the 2nd revision, and lot of revisions on the standards have already happened, but still we are discussing in a situation that there is electrical fire accidents. So practically, what is there in the standard book remains as a standard book. How much we are able to deploy it to the final person. There was a question about how to take it to the last person. Unless or until the last person is able to measure and make a corrective action, I don't think we have a society or a situation where we have free electrical accidents. Now, this is the 10 tests. You can refer it into IS 732, and also it is presented in 60364, and it is also there in NEC 23. These are the 10 tests. In the previous presentation, we spoke about floor resistance and wall resistance, touch potential and step potential. You can see it is mentioned there. Point number D, and there is also about point number E and F, which talks about automatic disconnection of supply and additional protection. It was very well explained in the previous session. But I have a quick question. When was the last time you have seen people doing touch potential and touch potential and step potential measuring in the field? When was the last time? You might have seen a situation where a transformer's insulation resistance has been checked, a winding resistance has been checked, cable insulation has been checked. When was the last time you have seen somebody have testing a floor and a wall resistance? And there is also this automatic disconnection of supply and additional protection, which we will briefly discuss about. That is about the loop impedance measurement. As sir was mentioning, it is mentioned in all the documents, 20 times, 30 times. It is mentioned in every document. But we are not testing it. That is the fact also. Added to this 10 test, there is also this programmable appliance test, which is every single phase equipment that you connected to your usage, and there is also power quality. As we were discussing, every testing, whatever we are saying, power quality itself is a topic. How to mitigate harmonics for a welding application, that itself is a huge topic to go around. But these are the 10 basic testings that you will have to follow. As per NEC 23, they say you have to follow it in a chronological order, in a sequential way, and you have to perform all the testings, and that is actually mentioned as a mandatory testings also. This is how you do a step potential and a touch potential. I'll also make it in a very interesting factor. I supply the testing equipments, but the customer do not want this accessory. See, it's not about the affordability, it is about the purpose of how I wanted to do the measurements. It starts also from the government tenders, it also starts with how a private company can do it. So this is about how you do a touch potential and a step potential for your informations. And this was shown in the previous presentation also about the path of electrical fault circuit. Now, we all agree to this scenario. There was a question about what is the impedance of a human body. Keeping theoretically, this is the path of an electrical fault. Now, in any design on the whatever we have, there is a protective device default installed. Let it be your MCB, RCD, whatever it is. The purpose of this protective device is to ensure that it trips. And the standard says you will have to do the testing twice in a year, and you have to have a record of this for 2 years, which means in 2 years backup you should be testing this like 4 times and keep the record. So in this total path of loop impedance measurement, what we try to do here is not a very complicated scenario. It's Ohm's law. You connect an equipment, you calculate what is the prospective short circuit current, and you are able to estimate what is the impedance of the circuit. It's not a complicated scenario. Where the complication will come is when you try to increase the voltage range, when you try to increase the current, when you try to get into the wind turbine application where the operating voltage could be higher. These are the places where it can get slightly complicated, but in principle, this is a simple Ohm's law. You connect an equipment, you calculate what is the prospective short circuit current. Then when you are able to see what is your impedance value, you can very well do it in any socket wherever we are connecting. And that impedance value, it is very well, it is mentioned in your standard document clearly for TN system, TNS system, this type of circuit breaker, what is the tripping time. After Mr. Gopakumar's presentation in the previous time, he mentioned that there is no B16 available in the market. Really, I tried to check it around. B16 is not available in the market. We tried to check it with the sources. So that kind of MCB, B type of MCB is not at all available in the market. Then comes the next protective device, which is your RCD device. So what we are trying to do in terms of testing, before I get into the testing, I wanted to briefly show you, I've been following the CEA website when the regulation was trying to be made. The first time they told, limit earth resistance sufficiently low. This was a previous standard, just a copy paste from the standard. So they told, limit earth resistance sufficiently low. Now the new statement says, limit earth fault loop impedance shall be maintained sufficiently low, which means what? We measure the earth resistance sufficiently low, keep it 0.5 ohm, 1 ohm, it is not sufficient enough. You need to know the entire fault loop value. We calculate the impedance of the total circuit, and then you can very well correlate and to see your, your standard document, which will say what is the tripping time or a characteristics as per the MCP. This is again an extract copy which is not published yet. You can go to the regulation part of CE and you will be able to see. Continuously it is mentioned, you have to test your impedance value. And you need to understand what is the value of your impedance. Not once, multiple locations. It's just a screenshot from the CE guidelines. They've also mandated a use of a loop impedance meter. This is a meter, to be very frank to you, this IEC 60364, this regulation is there for decades. This equipment is manufactured by us and we are supplying globally for 80 plus country. If I will sell 1,000 equipment to measure a transformer, I will sell maybe one equipment to measure loop impedance meter. Frankly, this is the statement. And RCD, which is also explained in the previous session, we are able to test the RCD also. Now, our history goes like this. We were able to manufacture a loop impedance meter approximately 30 years before. This is how our loop impedance meter looked 30 years before. Today, what we try to do here is, something have to be done in terms of deployment of such technologies to the market. So what we try to do is, we try to bring all the testings of IS 732 into one single equipment. The previous 10 testings, whatever has been shown, we try to bring all this into one equipment, which includes your soil resistivity, earth resistance, loop impedance measurement, RCD, tripping time, tripping current, power quality analysis. The same equipment you can take it to a EV charging station. The same equipment you can take it to a solar panel application also. So you will be able to use one single equipment to make all the kind of measurements. We kept this equipment outside. If you are interested to see, we will be able to showcase this equipment to you, which includes an insulation tester, earth tester, loop impedance meter, power quality analyzer, RCD meter, phase sequence meter, light meter, and these are the total testings that we will be able to do in a single equipment. And this is the technical specification, and in interest of time, I will skip the technical specification of the product. But only one point I wanted to emphasize on the results while I wanted to show you the product. Here, while we are deploying some new phenomenon, it's not a new phenomenon, but when we are talking about loop impedance, not many people will be able to know what is a loop impedance. Now to make a decisions on a loop impedance. So while we designed this equipment, so that you can also program it. You can take, this is the characteristic of a B16, you can include in my design. For example, if we talk about a railway application, you will be able to take this equipment, deploy your own characteristics of what is included in the design, then give it out to the market. So the engineers, while they carry out, they will be able to see whether it is pass or fail by themselves. So this is something that we tried to do while we thought out of the design. We saw people are interpreting the standards in a different way. They take their measurements and they interpret the standards in their own way, and they are not able to conclude whether it is pass or fail. So this is something that just how we do a measurement on a EV charging station and how the calculation is done. As I told you, it's not a complicated phenomenon. It's just simple Ohm's law. You calculate what is a prospective short circuit current, and you will be able to know what is the loop impedance value. Another important factor, because I come from the manufacturing side of this equipment, you might see from the manufacturers, usually, they say the accuracy of the equipment is 2%. But please also look into the number of digits. While we make a measurements on the low range of measurements, the digits could make a lot of difference. According to 61557, if you make a measurement of 1 ohm, it still falls within the limit, which is 6%. But when you make a measurement of 0.13 ohm, the error could go up to 30%, even when you choose a 2% accuracy. So please be a little bit cautious about while choosing the accuracy of this equipment. I will skip in the interest of time, because I see here my time is already done. So this is a portable appliance testing. It's a very simple equipment. You connect any kind of an appliance into this appliance tester, it will tell pass or fail. It is also mentioned in our NEC 23 that you have to do your portable appliance testing. Power quality analysis. The last point I wanted to conclude is, just last point. So in the CA regulation, already the safety standard is mentioned. That is already released to some, for the public, for the comments. But it is released document is already there for EV. For the electrical vehicle charging station, they clearly say the first point, which is talking about the applicant shall provide reliable protection system to detect various faults and abnormal conditions and provide appropriate means to isolate the faulty equipment. If you talk to any EV charging manufacturing companies, you will be able to come to a conclusion how many of them really know if there is an electrical fault, can they really protect. In the same standard, they talk about the power quality analyzer also, wherein you have to have a power quality analyzer there to make the measurements. So we have done some analysis on EV and PV stations. A quick overview about our company. This is a 30-year-old company, and we are in India for almost a decade. The list of customers, and if you have, this is the overall profile of our company. We operate on LT, HT, and the medium voltage circuits. This is the loop impedance is part of our basket. And thank you for your time. If you have any questions, I'm happy to answer it. Thank you.
Oh, thank you, Shyam. We have almost 700 registration for this conference. So your profile will be circulated to all of them, though they are not here. So wonderful presentation you gave. We will give you value for the money. I'll assure you that. Okay.